This conference will now be recorded.
Good morning, everyone. I welcome you all for today's 13th lecture on prestressed concrete structures. Yeah, see, I think still previous class, so we have finished how to calculate. I mean, what are the prestressing losses? So which are related to tension and post tension. At the same way, the losses which are relating to immediate action, right? Immediate loss, we can call it as, or the time dependent one. At the same time, the losses which are relating to the material of concrete and steel, right? So that's how we gone through 6 losses majorly. So one is elastic shortening, the second one is anchorage slip, and third one is frictional loss, fourth one is creep, fifth one is shrinkage, and the sixth one is, yesterday we discussed, relaxation of steel. Yeah. See, there is another loss, so which is called as a bending loss. See, because uh, when you stress more, okay, so as concrete usually have an elastic property, as it is a brittle material, still it have a few elastic properties in that. So by that, concrete will try to camber when you do stressing, okay, due to you know due to squeezing, right? So due to the compression forces into the concrete will become hard. Okay, we call it as the camber. So in that bending also will create some loss. Okay, so that is very minute. So but we need to consider that also. So when you're considering the total losses, okay, so that we call it as a bending loss, right? So there is no particular uh, involvement of the bending loss in all these 6 losses. So it's a kind of loss. So where we have to consider when you're calculating the total losses. The thing is when you try to apply the force within the limit, within the design force. Okay. So by that the pre-stress which is involved into the concrete will be as per the design. But when you try to pull more, okay, when you try to apply more force on it, so definitely the concrete may undergo beyond its limit. So then there is a possibility of bending loss also. Okay, that we need to consider it as an optional loss, right? So today we are going to discuss how to calculate the losses and what are the problems which are involved in calculating these pre-stressing losses. Okay, so because in the second unit there is a possibility of problems also. So in terms of calculating the pre-stressing losses. Okay, understand? So that is what very important. So now let's start the presentation with the comparison between RCC and pre-stressed concrete. Okay, so here we have to know how better the pre-stressed concrete relating with the real applications, at the same time the real loads which are applied in the real situations. Okay, so because when you start designing the member, so we have to consider its limit state of its strength and its serviceability. In, yeah, so in that way, considering few points or few concepts in terms of load bearing capacity, in terms of deflection, in terms of economy of the construction, in terms of impact loads, we call it as shock resistance ability, in terms of long spans. Okay, so in terms of even its self weight. So these are the considerations which we usually consider for the sustainability of the structure, isn't it? So sustainability in the sense it should carry good load. Okay, it should have a good carrying capacity. It should have less deflection. Okay, it should be very economical. Okay, and it should have ability to resist impact and short loads. Okay, or impacts and fatigue loads. Okay, it should be able to carry even the long spans also. Okay, without any support, member should be able to have a column free structures, we can call it as, or support free structures. At the same time, the self weight of the structure should also be less. Okay, so these are the major considerations. In that, if you compare the pre-stressed concrete and reinforced concrete, so you can find the difference very clearly. Let's first see the load bearing capacity. So the pre-stressing concrete will have more load bearing capacity compared with the reinforced concrete structures. So that is the first one. Second one is deflection. As you are making member to camber, making member to hog instead of bending, so obviously member will have very less deflection compared with the reinforced concrete. And third one is economy. So as we know, you can cast n number of members in terms of precasting materials. So by that, in pre-stressed concrete, you can go with the you can go with the precasting concept. So by that, the economy of the structure will be always less. So by that, economic than the RCC structure. And all RCC structures are a bit expensive. So why? Because it involves more with rebarring, okay, rebar reinforcements. So that's the reason. And coming to shock resisting ability, so obviously prestressed concrete will have very high resisting ability compared with the reinforced concrete structures. And the long spans, as we know, where the member is subjected to pre-stressing, so it will have more load carrying capacity even for the long spans. Okay, so why? Because you see, we all know when the span increases, obviously the self-weight of the member will make the member undergo deflection, isn't it? It's in its flexural strength also will get reduced. So while we are making member to having more compression stresses into, so where we are cambering the member, in that way, pre-stressed concrete structures will have more adaptable for long spans compared with the reinforced concrete structures. And coming to self-weight, as we know, it will have very much less weight compared with the RCC. Okay, so by comparing these many parameters, you can straight away go with the pre-stressed concrete instead of reinforced concrete structures. Okay, so for a huge constructions. So why? Because if you talk about cost, okay, for the for a limited construction activities, definitely the pre-stressing will be more in cost. Okay, you have to opt this for huge construction, for bulk production of precasting materials, or for infrastructure projects, it will be more economical. You can't say that for the small residential building, pre-stressed concrete never be an economical point of it. It won't be an cost free, right? So that is what the comparison we have to know between the pre-stressed and RCC structures. Okay. So now let's talk about losses of pre-stress. So we already gone through different pre-stressing losses. So here how to calculate the losses. Pre-stressing losses. So here we all know pre-stress loss is nothing but initial stress minus effective stress, isn't it? So let us take we are applying an initial stress of around 100 MPa, right? So do you think the same stress which is going to be infused into the concrete and make concrete to squeeze? So no. So there will be some losses. Take stress will reduce the stress which we are applying on the spans or tendons. Okay, so that losses we have to calculate in terms of calculating the effective stresses. I mean the stress which is effectively embedded into the concrete element. Okay, so initial stress in the sense the stress which we are applying, right? Effective stress means the stress which effectively embedded into the concrete. Okay, definitely that will be less. So what happens in between these two, initial stress minus effective stress? So the difference of these two will itself makes you to calculate the loss of pre-stress in terms of 6 parameters. Okay, so because let us take initial stress will be 100 and the effective stress will be around 85 to 90, then there is a 10 MPa of loss of pre-stress takes place. That 10 MPa, how it was distributed, okay, that distribution also we have to calculate individually based on the 6 parameters. Okay, as we know, like the parameters which we are calculating in terms of relaxation, in terms of anchorage and slip, in terms of friction, in terms of creep, shrinkage and all. Okay, now like time dependent one and immediate action. So this is what we are supposed to calculate the loss of pre-stress in terms of calculating the initial stress. In terms of differentiating the initial stress minus effective stress. Okay, so let's first talk about what do you mean initial stress. Okay, see, the initial stress is nothing but, so the deducting the loss So which is due to anchorage, okay, take up and the friction, and initial stress is going to be uptake. So how you are going to get the initial stress? So the initial stress you are going to consider by deducting the loss due to anchorage slip and the friction. Why? Why? Because let us take an example of pre-tension. So in pre-tensioning, what are the losses going to be happen for pre-tension member? There will be an elastic shortening, there will be a creep, there will be a shrinkage, and there will be a relaxation of steel. The anchorage slip and friction for pre-tensioned for pre-tensioning will be zero. Okay, so there won't be any kind of anchorage slip and friction loss for pre-tensioned member. So by that, whatever the initial stress we are going to calculate, here we have to reduce this anchorage slip and frictional, so to obtain the initial pre-stressing for pre-tension members. So in pre-stressing, what happens? In pre-stressing is going to measure at the time of pulling, obviously, the wire, and the stress is termed as the jacking stress. So where you are going to measure the stress which we are applying in terms of pre-stressing, so you are going to measure that pulling force. Okay, you are going to measure in the jacking system. Okay, in the stress jacking system, that jack system, you can able to measure the force, how much you are applying to pull the strands. Okay, so that in jacking stress is going to be treated as the initial stress. Effective stress is jacking stress minus all losses. Okay, so here you have to calculate all the losses individually, and you have to minus that in the jacking stress. Why? Because jacking stress will give you the initial stress which you are applying on the strands. Understand? So the jacking stress are nothing but the initial, nothing but the stress which we are applying. Okay, so by that, minusing with your jacking stress with losses, you are going to get the initial stress. Okay, so this is how the initial stress is going to be calculated. And next, coming to the effective prestress. What do you mean effective prestress? So here effective prestress is nothing but the losses which you are going to get, right? So even with this formula also you can able to calculate. Effective prestress nothing but initial prestresses minus losses. What are the losses? So losses, the summation of all the individual losses will give the complete losses. So here the initial prestress in steel minus losses is known as the effective or the design prestress values. Okay, so here that is how the effective prestress values you can able to calculate by knowing the initial prestress and by knowing the losses. Okay, so here the important parameter is calculating the losses. Why? Because initial prestress values you are going to get from the jacking system, right? From the jacking system you can able to get the initial prestress. So once you calculate the losses, so the differentiation of these two, difference of these two will give you the effective prestress, which is supposed to be induced into the member. Okay, which is supposed to be induced into the concrete member. Okay? So that is what an effective prestress. Okay, so here the total amount of losses. So according to the pre-stressing system, right? So here first let me show you the pre-tension losses. What are the pre-tension losses? The loss due to creep, the loss due to shrinkage, loss due to shortening, and loss due to relaxation. So why? Because anchorage slip and friction loss is negligible in pre-tension losses, isn't it? So then what are the total losses in post-tensioning? Loss due to creep, loss due to shrinkage, loss due to elastic shortening, loss due to relaxation, loss due to anchorage slip, and loss due to friction. So that means all losses will be considered in post-tensioning loss, and only 4 losses will be considered in pre-tension losses. So this is how the summation of losses are going to be calculated to calculate the effective stress which is particularly involved into the member. Understand? So this is how you are going to calculate. So now our major target is here to calculate individual losses based on some kind of empirical formulas. How to calculate creep loss, how to calculate elastic shortening loss, how to calculate shrinkage loss, how to calculate relaxation loss, how to calculate anchorage, and how to calculate friction. So this is what individually we are supposed to know to calculate these kind of losses. Okay, so this is what about the total losses which gives you the effective stress which is involved into the concrete, right? Yeah, so the total losses here it is difficult to generalize the amount of loss of prestress because it is dependent on so many factors. So that's true. Why? Because so there are around 6 losses. Do you think that calculating all these losses with some kind of empirical formulas is that easy? No. So why? Because uh, as we discussed all the losses, let's talk about creep, let's talk about shrinkage and all. Every loss is going to be happen because of many factors. Okay, so every factor is going to plays a vital role in terms of calculating that loss. And one more thing here, uh, creep, shrinkage, and relaxation losses are time dependent one, right? So time dependent one, what happens in the structural element, the prediction of that is very difficult. Okay, that is the reason why it is not that easy to generalize the amount of losses which you are going to calculate, the total summation of the pre-tension or the post-tension losses. Okay, but majorly some factors we can directly consider to calculate the total losses, which won't be a 100% accurate. Okay, so generalizedly we can consider these factors which are going to be which are going to be considered for calculating the total losses. What are they? The first one, properties of concrete and steel. That those these factors are very important to calculate the total losses. What are the properties? See, there are many properties for concrete and steel. Let's start from Young's modulus. So concrete Young's modulus will be there, steel Young's modulus will be there, right? And the strength properties of concrete and strength properties of steel. Okay, we call it the mechanical properties. So properties in the sense we are much bothered about the mechanical properties in terms of creep, in terms of shrinkage, in terms of Young's modulus, in terms of strength. Okay, so like this, there all parameters are going to be considered as a factors to calculate the total losses individually, right? And the next one is curing and moisture condition. That is also very important. Why? Because curing and moisture condition is going to relate more with the shrinkage loss. Okay, so by that, out of many factors or many parameters, generalizedly we can consider a few factors where in which we can able to calculate the total losses, okay, independently. So one is curing and moisture condition. That is also very important. And the next one is magnitude and the time of application of prestress. That is very important. So the magnitude in the sense the amount of force which you are applying on the strand, okay, is very important. Okay, that relates it. So you have to consider the magnitude of pre-stressing force as per the design. Okay, so the amount of force which you are applying on strands is very important. If you go beyond or if you go less than the design force, so definitely so the losses will take place, right? And the time of application of pre-stress when you are applying the pre-stressing force, either in post-tensioning system or pre-tensioning system, when you are applying, at which time you are applying. Okay, so it says that if first your concrete is supposed to get its first concrete should get hardened. At the same time, concrete should have its maximum compression strength, which is to be attained. Then only you can go for pre-stressing. Okay, so that is what a very important point: magnitude and time of application of pre-stress. And the last one is process of pre-stress. Which process you are implicating for doing this pre-stressing system? What type of process you are considering? Okay, are you are stressing only from one direction? Are you stressing from both the directions? Okay, are you using what type of methods for doing pre-stressing, right? So what type of jacking systems which you are using? So this all comes under the process. So the process of pre-stress also is going to be one of the major factor in terms of calculating the total loss. Okay, these four are very important. Apart from this, there are many factors, but as there are many factors, major factors which we can consider to calculate the total losses or the losses which are going to rely on these kind of factors. Okay, properties of concrete and steel, curing and the moisture condition, magnitude and time of application, and the last one is process of pre-stress. Okay, please try to remember all these. Okay, so because even in competitive exams or even in interviews, they're going to ask how to how you are calculating the total losses, and what are the factors which are going to be involved in calculating the total losses. So I think you can mention all these. So out of which if one or two are not considered properly, so definitely the loss which you are going to calculate won't be effective. Okay, so which is not at all going to be effective. You can't calculate the effective pre-stress properly. Okay, when you are not considering all the factors, okay, independent. And the next one is, as we know, the pre-stressing laws. Okay, so now I will straight away go through, because this is an additional slides, so which gives more information about the pre-stressing laws and what are the different types of losses. So because till I mean in the previous classes we gone through all the pre-stressing losses individually. So but here there is another presentation, so which gives more information about pre-stressing losses. So here I'm not going to discuss all these points again, so because this we already discussed. Okay, so as we know, the losses of Prestress are classified into two: short-term or immediate loss. The second one is a long-term or a time-dependent loss. Okay, immediate loss and a short-term losses and okay, time-dependent losses and long-term losses and okay. So as we know, like the short-term losses or immediate losses means what? Immediate losses which are occurring during pre-stressing. Okay, so what are the losses comes under immediate losses? What? Anchorage slip, elastic shortening, and the next one is frictional loss. So these are the one which are going to happen immediately, okay, while doing pre-stressing, right? And the next one is long-term pre-stressing, sorry, long-term losses, which are nothing but time-dependent losses. So what are the losses comes under the long-term losses? Creep, shrinkage, and relaxation of steel, right? So you have to, you know, um, remind all this. And one of the important effect, okay, the other name for a friction between tendon and the tendon duct is nothing but a wobble effect, okay, because in the yesterday's quiz there is a question under wobble effect, right? What do you mean wobble effect? Because when I discussed about frictional loss, so the frictional loss in the sense, so before friction the duct and the strand, okay, won't be have any contact, right? So when you start stressing, what happens? Your strand will touch the duct surface, okay, then the friction starts, okay, there the frictional loss starts. That effect is going to be called as an oval effect, okay, the friction between tendon and tendon duct, దాన్ని duct అంటారు, లేకపోతే sheeting అంటారు, okay, so or some kind of a profiling pipe అంటారు, okay, there are different nomenclatures when you go practical, okay. So the friction between the tendon or a strand, okay, and the tendon duct or a strand duct is called oval effect. So the immediate losses are, as we discussed, elastic shortening of concrete, slip and anchorages, which are immediately after pre-stressing, and the friction between strand and the strand duct, okay, which is called as an oval effect. And what are the time-dependent losses? Creep and shrinkage and relaxation of pre-stressing steel. Okay, so even you have to differentiate with respect to the material also. Okay, so material paranga kuda you should able to differentiate the losses. Okay, so that's all. And next one is immediate losses. So this we all know when మనం discuss చేసామమ్మ. So straight away I will go how to calculate the elastic shortening. Okay, ఈ discussion అంతా elastic shortening గురించి. So here in this presentation more information is given. So why? Because earlier PPT and this PPT will use you more information to attempt your assignment 2. Assignment 2 లో there are a few questions on pre-stressing losses, right? So వీటిని మీరు ఒకసారి brief గా చదువుకొని you can write on your own. Okay, so for that I am sharing another presentation. So from this you can able to get more information on pre-stressing losses, right? So next, now in the elastic shortening, I will straight away go with the calculation, how to calculate the elastic shortening for pre-tension member and post-tension member. Why? Because elastic shortening is the loss, so which will be there for both systems, pre-tension system and post-tension system, isn't it? So here in the pre-tension member, what happens when the tendons are cut? As we know, the pre-stressing force is transferred into the member, where the member undergo some kind of contraction, okay, some kind of shortening. So that shortening is called elastic shortening, okay, that we know. So, and what do you mean post-tension member? If there is only one tendon, there is no loss. Okay, so when there is a group of tendons, when you are stressing them subsequently one by one, then there is a elastic shortening takes place. So that's also we discussed in elastic shortening, isn't it? Okay, so these are the pictures of a pre-tension member, and this is a picture of a post-tension member, right? And now straight away we'll go to the calculation. How to calculate the elastic shortening loss? Okay, so here the linear elastic relationship is going to be used to calculate the stress. Okay, what stress? Elastic shortening stress man calculate chestam. So here try to remember all these losses we are going to calculate in terms of stress. Okay, so why? Because total losses are nothing but what? The difference between initial stress minus the stress which is going to be involved into the member. Okay, so by that the losses which we are going to calculate, they are called pre-stressing losses. So by that the losses will be in terms of stress only, right? So in that way, so first one is elastic shortening loss. How you are going to calculate the elastic shortening loss? See, for this now you have to go back to your strength of material subject. Okay, strength of materials మీకు unit 1 నేను చెప్పాను కదా మీకు. నేను చెప్పేది I mean when you had this concept called composite materials. Okay, when you are calculating the uh, total strain for a composite material, total stress of a composite material, how you calculate it? See, when the composite member, when it is subjected to load, what happens? When it is subjected to load, there will be an equal strain. Let us take a composite material of steel and concrete, right? So let's start applying some force on the composite material. So whatever the strain, or I mean, because stress is directly proportional to strain, whatever the stress carried by materials, okay, so the strain also will be same even in the concrete and steel. So why? Because individually members will have different strains. Understand? So steel and concrete will have different strains based on the application of the load. But when the member is a composite material, what happens when it is subjected to load? Okay, so both will act as a single member. So by that the strains of steel and concrete will be same. So now you can see the relation over here, the qualification of the losses which are going to be explained very clearly. Delta FP is equal to EP into delta epsilon P. What do you mean that? Delta is nothing but summation of all pre-stressing. Okay, P ante stands for pre-stressing anamata. Okay, pre-stressing of steel. అర్థమవుతుందా? F అంటే స్ట్రెస్, P అంటే స్ట్రాండ్, స్టీల్ యొక్క స్ట్రాండ్ అన్నమాట. EP అంటే స్టీల్ యొక్క యంగ్స్ మాడ్యులస్. ఎప్సిలాన్ P అంటే స్టీల్ యొక్క స్ట్రెయిన్, సమ్మేషన్ ఆఫ్ strains which are developed in the strands. Okay, so because we all know stress is equal to Young's modulus into strain. Why? Because Young's modulus is equal to stress by strain. Stress is equal to Young's modulus into strain. So now EP into epsilon P ni epsilon C and rasan, right? So if you follow my cursor, this epsilon P became epsilon C. Why? Because as it is a composite material, whatever the strain carried by steel will be equal with concrete, right? Until the concrete and strain outundo, steel also will have the same strain. So by that epsilon P will be equal to epsilon C, right? So let's use pointer. So epsilon P is equal to epsilon C. Why? Because as it is a composite material, composite materials will have same strains, right? So by that epsilon P can be written as epsilon C. So EP, Young's modulus of steel, how can you write the epsilon C? As we know, Young's modulus of steel, sorry, Young's modulus of concrete will be equal to stress in concrete by strain in concrete. Antena? Young's modulus of concrete is equal to stress in concrete by strain in concrete. So how can you write the strain in concrete as stress in concrete by Young's modulus of concrete? Right? So by that FC under sigma C by EC and right? So what is EP by EC? EP by EC అంటే Young's modulus of one material by Young's modulus of other material. Antena? So because in a composite material, two materials will have different different elastic properties. By that, Young's modulus of steel will be different than Young's modulus of concrete. So now this equation can be written as EP by EC of sigma C and right. What is EP by EC? EP by EC is nothing but what? Modular ratio. Under. Okay. M is nothing but modular ratio. What do you mean modular ratio? Modular ratio is defined as ratio of Young's modulus of one material by Young's modulus of other material. Okay, it might be any material, right? So that's finally the loss in steel. Steel and strand. The loss in steel, summation of all losses in steel is equal to modular ratio of steel by modular ratio of concrete into stress of concrete. Okay, so this is how you can able to calculate the losses due to elastic shortening. Okay, so for simplicity, the loss in all the tendons can be calculated based on the stress in concrete at the level of CGS. Okay, so for making a more simpler way, so here the calculation of all these losses which are going to be happened in steel particularly, okay, which are going to be happened in tendon. Why? Because here the loss will be there even for the steel also. So why? Because in pre-tension member, so when the strands are cutted, okay, when strands are cutted at the both ends, along with the concrete, the steel also will get squeezed, isn't it? So by that, the loss in all the tendons which are going to be calculated based on the stresses in concrete at the level of CGS. What do you mean CGS? Center of gravity of strand. అర్థమవుతుందా? ఇక్కడ స్టీల్ అని నేను చెప్పట్లేదు, ఐఎమ్ గోయింగ్ టు కాల్ ఇట్ యాజ్ ఎ స్ట్రాండ్. వై? బికాస్ హియర్ వీఆర్ యూజింగ్ స్ట్రాండ్ యాజ్ ఎ టెన్షన్ మెంబర్. ఓకే, సో అందువల్ల ఇన్స్టెడ్ ఆఫ్ స్టీల్ ఐఎమ్ గోయింగ్ టు కాల్ ఇట్ యాజ్ ఎ స్ట్రాండ్. సిజిఎస్ అంటారు. సిజిఎస్ అంటే center of gravity at strand. CGS. Okay, so this simplification cannot be used when tendons are stretched sequentially in a post tension member. So that's what very important. So here the CGS or the same formula, it can be used for pre-tension member but not for the post tension members. Why? Because in post tension members the members are going to be stretched sequentially. Okay, so by that you can't use the same thing, okay, for post tension member. So in the next one, this is how you can able to calculate the elastic shortening loss. Okay, so and where you need to know these parameters. Okay, so అందువల్ల చెప్తున్నాను. So here in the previous slide which I mentioned very clearly how to calculate the losses, what are the factors going to be involved. In that, one important point is that the properties of materials are the important factor to calculate the total losses kada. Mari ivanni properties e kada. Stress is a property, Young's modulus is a property, okay, strain is a property. So by that, these are all important properties which are considering as a factors to calculate the total losses, out of which one is the elastic shortening. Okay, understand? So that is how to calculate the elastic shortening. Okay, the next one is anchorage slip. So what we discussed about anchorage slip, anchorage slip won't be there in pre-tension member. Anchorage slip will be there only in post-tension member. Okay, so why? Because in pre-tension member your concrete is not casted along with the strand. Okay, so because after stretching the strands only the concrete is going to be casted. So by that, this anchorage slip will having a chance there only in post-tension system. So why? Because here the tendon force is going to be transferred from jack to the anchorage ends. Okay, force anedi jack nunchi anchorage ends ki transfer avutundi, right? So because that will happen only in post-tension system. In pre-tension system there is no there is no possibility of transferring force from jack to the anchorage ends. Why? Because the stressing is done before the concrete casting. So by that, the friction wedges slip over the small distance. Why? What we are considering in anchorage slip. So here there will be some slip takes place between the strand and the wedge. So strand ki wedge ki some kind of slip jarutundi. Slip ante enti jaradam. So that wedge slip is going to be considered as an anchorage slip, which will be happen only in post tension system, right? So we already discussed all these points in previous classes. What do you mean anchorage slip? How the anchorage slip is going to be takes place for in between wedge and the strand and all. So here one of the important parameter is anchorage slips are won't be uh, independent. Okay, so it always depends on number of the size of the strands. So ఎలా ఉంటుంది మనకి strand? So it will be around 3 ply strand ఉంటుంది, okay, 5 ply strand ఉంటుంది, 7 ply strand ఉంటుంది, 9 ply strand ఉంటుంది, 12 ply strand ఉంటుంది. So ply in the sense each wire is called as a ply. So when you wind the plies, we call it as a strand. So for every different dia of strands, there will be different anchorage slips anamata. Okay, so by that the anchorage slip is always depends on its size, depends on its diameter of each individual ply along with the whole diameter of the strand. Okay, so that we need to understand. So here the anchorage slip, how you are going to calculate, what is the notation of calculating the anchorage slip. This all we can able to understand from this slide. So here an important point: loss of stress is caused by a definite total amount of shortening, we all know, and the percentage loss is higher for shorter members. See, these anchorage slips are very loss will be huge for shorter members. For long members, the anchorage slip will be very less. So that's the reason why what we do for long members, we go for post tensioning in terms of retention. Understand? So that's the reason why here short members ki the anchorage slip chala ekku untundi. So that's the reason why we'll go for long spans where it is very easily optable for post tensioning in terms of retention. Okay, so here the effect of anchorage slip is present up to a certain length. So that length we called as a setting length. Okay, so why? Because the anchorage slip is always depends on the length of the wire. Okay, length of the wire, but the holding of the wire by the wedge is always depends. So by that, the effect of anchorage slip is going to be represented in form of a setting length. Okay, so we represent that in form of a setting length, which is denoted by symbol L set under. Okay, so how to calculate the L set? Okay, so from this slide you can able to understand clearly. So here the loss of stress due to anchorage slip can be calculated with the formulas. Again, see, ఇక్కడ మీకు కనిపిస్తున్న formulas ఏవి కొత్త ఏం కాదు, because you already studied all these in your strength of materials. That's what I told you many times. Strength of materials and design of RCC structures are the prerequisites, and concrete technology are the prerequisites of prestressed concrete. Okay, if you are good in all these three subjects, understanding prestressed concrete is very easy. Okay, you have to know the different properties and factors and the design things of all these different materials, from strength of materials and RCC structures and even the concrete technology. Then you can able to understand this PSC subject easily. Okay, so here the loss of prestress due to slip can be calculated from the formula. So P by A is equal to ES into delta by L. What is that? P by A stands for stress. Okay, delta by L stands for what? Strain. Okay, stress is equal to n small s into strain. So delta is what? The slip of anchorage. What is delta? Here we are considering delta as changing length. Delta is nothing but a changing length. So what do you mean strain? Strain is equal to changing length by original length, isn't it? So here the changing length we are going to calculate in terms of slip. So why? Because from the wedge the strand will slip, right? So that slip is going to be measured with the help of a scale. Okay, so if you see practically, so in practical the wedge slip can be measured easily from the on the surface of the strand. So దాన్ని మనం measure చేస్తాం అన్నమాట. That length is going to be considered as a displacement, change in displacement. So we call it as a technically we should call it the slip of anchorage, right? So that slip of anchorage is going to be considered as a changing length, and L is the length of cable, and A is nothing but cross sectional area of the cable. Here we are going to consider all this for cables. Why? Because anchorage slip is a material related to steel, not for concrete, isn't it? So it is a material loss relates to steel. So by that, slip of anchorage on cable we have to consider length of cable as a length, cross sectional area of the cable as cross sectional area, Young's modulus of that strand, which is made up of steel. So by that E is to be considered, and P is nothing but pre-stressing force on the cable, which is a carrying capacity. Okay, or the application of the pre-stressing force, we can call it as. So these are the one which we are going to consider all this. From this, you are going to calculate the slip of anchorage. Our delta ni man calculate chestam. That delta will use the slip of anchorage. From this slip of anchorage, you are going to consider the loss of pre-stress due to slip. Okay, a slip valla enta loss jarigindi anedi manam calculate chestam. Okay, so how you are going to calculate that? Here you are going to calculate in terms of pre-stressing force, or you can calculate in terms of pre-stress directly. Why? Because P by A stands for what? Stress. Okay, so here P by A stands for what? Stress. What stress it is? Anchorage slip stress. Anchorage slip stress is going to be considered as a anchorage slip loss. Okay, so this you are going to summate with the total losses. Total losses will be the loss and matter. Okay, sigma s. Sigma s is nothing but P by A. So this sigma s is going to be calculated from slip of anchorage, which you are going to measure from the surface of the strand. Okay, so this sigma s అనేది మనం కన్సిడర్ చేస్తున్నాం. This is nothing but a anchorage slip loss. అర్థమవుతుందా? సో ఈ సిగ్మా ఎస్ ని మనం క్యాలిక్యులేట్ చేస్తాం. ఎర్లియర్ స్లైడ్ లో మనం ఏం క్యాలిక్యులేట్ చేస్తున్నాం? ఇన్ దిస్ యు ఆర్ గోయింగ్ టు క్యాలిక్యులేట్ దిస్. సో దిస్ ఈజ్ నథింగ్ బట్ వాట్? సిగ్మా టీ యాజ్ ఏ ఎలాస్టిక్ షార్టనింగ్ ఆఫ్ ప్రీస్ట్రెసింగ్. ఓకే, అండ్ ఎలాస్టిక్ షార్టనింగ్ ఆఫ్ ప్రీస్ట్రెస్ లాస్. ఇది ప్రీస్ట్రెసింగ్ లాస్ అన్నమాట. ఓకే, డ్యూ టు ఎలాస్టిక్ షార్టనింగ్, రైట్? అండ్ నౌ హియర్ దిస్ ఈస్ anchorage loss. Okay, అన్ని stresses లోనే ఉంటాయి. All we have to calculate in terms of stresses only. Why? Because pre-stress loss ante which will be in terms of stresses. Okay, so that's what about the anchorage slip loss. Clear? Right, so these two we discuss, and further losses, how to calculate the further losses, everything we will study in the further sessions. Okay, so now till this slide, okay, till this calculation of elastic shortening loss and anchorage slip loss. Any doubts? You can ask me. Yeah. So the time is 11:46. So we have 14 minutes time. So any doubts, you can ask me now. Please. So now the strength is 36. Very good. So any doubts, Amma, related to calculation of anchorage slip loss and elastic shortening loss? Any doubts? See, for both these losses, the only thing is you have to know the formulas of stresses and strains. అంతే, యంగ్స్ మాడ్యులస్ ఇవి తెలిస్తే మీకు ఈ రెండు లాసెస్ ఈజీగా క్యాలిక్యులేట్ చేయొచ్చు. Do you think that is tough to remind? హలో, చెప్పండి. నేను క్లాస్లో ఉన్నా, చెప్పమని చేస్తా 10 minutes. క్లాస్లో ఉన్నాను. ఓకే, ఓకే, రైట్. సో ఏమైనా డౌట్స్ ఉన్నాయమ్మా ఈ రెండు లాసెస్లో? సో బై దట్ in the next coming classes we will discuss about how to calculate the frictional loss, how to calculate creep loss, shrinkage loss, and the relaxation of steel loss. Before manam chuddam. Okay, and we will try to solve few more problems on all these losses. Anni individual losses meeda konni problems kuda solve cheddam. Okay, so by that we can able to understand these pre-stressing losses clearly. Any doubts? Mithun, I will call one by one. Roll number H2. Please respond, number H2. Roll number H2. Ganesh. Roll number 108. Please respond. At least you can respond to chat box. Roll number 108.
Yes, sir.
No doubts, ma'am? Clear? B. Vamshi. Vamshi. Roll
No
number
doubts,
11.
sir.
Roll
No
number
doubts.
13. Clear on the answer?
Yes,
Roll
sir.
number 13. Yeah. Roll
Yes,
number
sir.
120. 122. 126. Any doubts, Amma, in the calculation of elastic shortening and anchorage slip losses? Roll number 126. 135.
నో సార్
వింటున్నారా లేకపోతే జస్ట్ ఏమి లేదంటున్నా ఊరికే అంటున్నారా? నిజంగా అర్థమైందా మీకు? క్లియర్? 136. 138. రోల్ నెంబర్ 138. ప్లీజ్ రెస్పాండ్. అందరూ రెస్పాండ్ అవ్వాలమ్మా. 138. అట్లీస్ట్ యూ కెన్ రెస్పాండ్ త్రూ చాట్ బాక్స్. 136. 138. 147. Roll number 147. 148. 155. 159. 159. Prudvi. Lateral 102. 105. 106. Lateral 106. Lateral 108. 108. Arun 143. Sarojini 118. Please respond. Naveen 107. Lateral entry 107. Naveen. Sri Indu 101. 101. Gopi.
Clear, sir.
Clear. Everyone. It was clear, clear, clear. So you people are not asking any doubts, Amma. I'm not happy. Hindu, Gopi, Rashekar. Rashekar, Lavanya. Mithun.
Clear, sir.
Clear. Mohan.
Clear, sir.
Mohan. Nikita. Prabhu. Prabhu. Raju. Shivkumar. Shivkumar. Any doubts? Srinija. Srinija. Vinay. Any doubts? No doubt. No doubt. Okay, we'll see. Their assignments ఎలా రాస్తారు? Let's see. In there, I will try to, understand how better you understood about these topics. Antena? Right. So that's what for the today's class, right? So tomorrow, I mean the next class, I think Monday. Possibly, if there any chance, I will take one class on Saturday. Okay, based on the request. So if there any chance, I will come on Saturday where we will continue with other 4 losses, calculation of frictional loss and other 3 more losses. Okay. Sir, axial pre-stressing chapter once. Axial pre-stressing chapter. I mean, what do you mean like axial pre-stressing in the sense? See, all longitudinal pre-stressings will be in terms of axial pre-stressing. Let us take a beam. Okay. So let us put a stand inside. Okay, in that. So whatever the force you apply, okay, so let us consider that in a pretension. So what you do, you will apply force through its axis, isn't it? So when you are applying force through its axis, where the force is transferring through the center of the section, okay, so that forces will be an axial pre-stressing forces. So where the member should coincide with the axis of the whole compound member. Let us take a beam. So beam centroidal axis of the ground ఉంది. Okay, so if your stand is placed at the center of the section itself, so there the force will be axial only. Okay, so let us take the rectangular section where your stand is not at the center, it is below the center, where it is having some kind of eccentricity from the centroid of the section. So there it will call eccentrical stressing. Okay, axial stressing ante the stressing which we are applying through the center of gravity of the whole section. Eccentrical section in the sense there will be some eccentrical distance from the center of the section to the applied force point. Okay, that is called an eccentrical prestress. Okay, Mohan.
Okay, sir. Clear.
Okay.
Clear, sir.
Yeah. Anything else? That's it. Okay, so now the night time is 11:55. So by that you can ready for the next class, right? So that's it, guys. So I think yesterday I have shared you assignment to 2 questions and the format also, even the submission link. Okay, so all there. Please try to write on your own. Don't try to copy from your friends or from the internet. You can make use of my presentations for writing answers for that. Okay, so please try to write on your own. Okay, then you will be out of playlist. Okay, na? So that's it. Then take care, guys. See you in the next class.